Okay, next let's look at the further optimization or improvement of the time complexity of the same problem. So they propose they can uh, find the k smallest element from the main heap using big O of k times 3 to the power of log star k time. Okay, so let's first clear this definition of log star. So in computer science, for example, if we use the number n, so this log star n means if n is smaller than or equal to 1, then this log star n is 0. If n is greater than 1, this log star n is equal to 1 plus log star log n. So it's basically a recursive of log computation. And the way they can realize this time complexity, they extend the previous scheme recursively. So because it's a recursive algorithm, also that's the recursive log computation comes from. And they set a k as a positive integer, and this curly h, they name it a forest of at most 2k heaps. Okay, so this algorithm solves this problem in this way. It recursively calls the procedure RSEL2, which is a recursive SEL2 with the parameters h0, 1, and k. And this procedure RSEL2 HLR returns the R smallest elements, and this L is a level number. And let's look at this RSEL2 step. So this procedure, if R is equal to 1, which is the smallest element, then it returns the smallest value among the roots of the heap in curly H, which is straightforward. Otherwise, it partitions the curly H into subsets, and each subset except at most one subset containing 2 times log R heaps, and remaining at most one subset containing fewer than 2 log R heaps. And for each subset curly hi, it recursively finds the log R smallest elements in hi. Then designate these elements as clan Ci and determine the offspring OSCI. And set the port relation Ci to the set of roots of heaps in hi that are not in Ci. Then initialize an auxiliary heap HL with the representatives of the clans Ci. So for R over log R times, it performs an extract min operation in HL. Let Cj clan J be the clan represented by the extracted elements. Then recursively at level L plus 1, find the log R smallest elements in the subheaps rooted as at member of offspring Cj. And let this be clan Ci, and I minus 1 is the number of clans found up to that point. Determine offspring Ci and the port relation Ci. If port relation Ci is not empty, which means if it exists, then recursively find at level L plus 1 the log R smallest elements in the subheaps rooted at members of port relations Cj, and let this be clan Ci plus 1. Then determine the members of the sets offspring Ci plus 1 and the P port relations Ci plus 1. Insert the representatives of Ci and Ci plus 1 into HL. So when this loop terminates, take the last element and identify the set of elements in H less than or equal to this element. Select the rth smallest element in this set. And so that we can find the kth, the rth smallest element in this set. So that completes the description of the recursive procedure RSEL2 we mentioned before. Okay, now let's look at the proof. So the correctness, since it's a recursive procedure, the correctness is similar to the previous method with big O of k times log k. And we'll just mainly look at the time complexity here. So the time to find the elements to initialize heap HL is dominated by performing at most R over log R recursive calls on log R size problem. And to set up the heap and perform R over log R extract min and 2 times R over log R insert, that time complexity is big O of R. So for each extract min operation, there are 1 or 2 recursive calls of size log R, and 1 for the offspring, 1 for the port relations. If the port relations exist, that's 2 recursive calls. If it doesn't, then it's 1 recursive call. So finding the rth smallest from all elements in H less than or equal to the last representative is big O of R. The elements will be only in the at most 3 times R over log R class. And so this is the time complexity. When R is equal to 1, T of 1 is less than or equal to C. And when this R is greater than 1, so this time T of R is bounded with C times R plus 3 times R over log R times T log R. So if we apply the recursion, then we can eventually get the T of R is bounded by big O of R times 3 to the power of log star R. So this is some explanation of this paper, and hope it helps. Thank you.